A tree on a sloping hill casts a shadow 45 meters down the slope of a hill. The gradient of the hill is 12 over 60 and the angle of elevation of the sun is 35 degrees. How tall is the tree? To the nearest tenth of a meter, so to the nearest 0.1 of a meter. This is quite complicated. Obviously, the main complicated part is drawing a diagram. So I think I'm going to start with this sloping hill, which has a gradient of 12 over 60, with sort of 1 in 5. So if you think of a gradient, you can think of that as y step over x step. So 12 over 60 is the same as 1 in 5. So basically, this goes for every 5 steps to the right, you need to go 1 up, 5 right, 1 up. So it's quite a shallow slope. So let's start with the slope, something like that. That's the sloping hill. Then we need a tree. We're going to assume that the tree stands upright. So there's a nice choice, not very good. I could be the other branch. Something like that. There's a nice tree. Okay, so then we are going to have this angle of elevation up to the sun. So if I want to measure any kind of angle of elevation, remember that is if you were pointing your head directly horizontally from the point where you're observing from, so that's going to be the point from the end of the shadow, then basically it's how much you have to turn your head up to be looking at the target. So if we kind of take this can be the length of the shadow, and then we need a horizontal line, something like that. Definitely going to need that. And we're also going to have this angle here up to the tree, sorry, up to the sun, like that. So let's say the sun can be up here somewhere. Okay, now we were told the angle of elevation to the sun is 35 degrees. Remember, angle of elevation is deviation from horizontal. So this angle here, that is your 35 degrees. Then we've got a length of shadow 45 meters. So I'm going to draw a shadow in a different color. Red, nice red shadow. That can be 45 meters. Like that. Okay, so the next thing we need to work out is probably another angle. So what we can work out is using that gradient of the hill, we can work out an angle, another angle in here. So maybe this green angle. And remember what we've done in very recent lessons, we've realized that tan angle is the gradient. So tan theta is the gradient. We've decided the gradient of this is 1/5. So basically, tan theta, I'm calling this little green angle here theta, equals 1/5. So that must mean theta equals the inverse tan of 1/5. It's not a nice value that we can do without a calculator, so we will use a calculator. Inverse tan of 1/5. That gives me 11.3 degrees. 11.3 degrees there. If that is 11.3, then we can also work out this little angle in here. The purple angle is going to be the difference between 35 and 11.3. So 35 minus 11.3. You can go to your calculator, so you can use the A and S button as much as anything else. So 35 minus ANS gives us 23.69, so 23.7 degrees. Okay, now the one thing we actually want to find, the target, is the height of the tree. So we want this height here, we call that H. So if you think about what we've got, if we take this whole purple triangle like that, we have an angle in it. So we've got this 23.7 degrees. We've got 45 as a distance. We've got height we want to find. So if we can just get this angle here, then we will be able to apply the sine rule, because we'll have two pairs of opposite sides and angles, and we'll have, out of those 4 numbers, we will have 3. We only need 1, so we'll be able to do that, but we need to get this angle first. And the way to do that is to extend this line down here, and we know we have a right angle. And actually, if I just consider this whole triangle up here, so we've got that red triangle, they have this common angle. So the red angle, the purple angle is exactly the same angle, and I can work that out using the right angled red triangle, because we've got angles of 90 and 35 degrees. So this is 180 minus 90 minus 35. So we can use that one without a calculator. 180 minus 90 is 90. Take away 30, take away 5, 60, 55 degrees. Okay, 55 degrees. So now using the red triangle, and I'm just going to draw it so we're clear exactly what I'm doing. We've got 55 degrees here. We've got h that we need to find. We've got the length of the shadow, that's 45 meters. And we have this little angle here, which we calculated to be 23.7 degrees. And I've got the long number saved on the calculator, so that's quite handy. So 23.7 degrees. Okay, so now we can look at the pairs of opposite sides and angles. So you've got your 55 is opposite the 45, and 23.7 is opposite h. Always start with what you want first, that is the h. So h over sine of the angle opposite, sine 23.7 equals the other side, 45, over sine of its opposite angle, sine 55 degrees. So that means that h equals 45 times sine 23.7 over sine 55. Okay, go to the calculator and you're going to type in 45 times sine, and we're not going to write 23.7, we want to use as much accuracy as possible. So we use the ANS key, as we already have the numbers as the last answer that came up, over sine 55, and we know 55 is exact anyway. So that gives us an answer of 22.07. We've been asked for it to one decimal place, so h equals 22.1 meters, and that is the height of the tree. Should always just have a look to see if it looks sensible. And 45, yeah, I think that's probably reasonable.